Alright, this is the answer key to the review for drawing free body diagrams and looking if the forces are balanced or unbalanced, whether the object will be at rest or in motion, or whether the object will be moving in a particular direction. So this will be our answer key. So first we'll look at the situation. So you have a 1 kilogram book at rest on a tabletop. So let's draw force body diagram. So definitely the object experiences acceleration due to gravity, so there's always force of gravity. And then there is an contact between the stable object, which is the table, so you have normal force. So let's take a look at the sum of the forces on the x, which is the horizontal. There are no forces there, so we will write 0. What about the one on the vertical? There are 2, so it's forces on the y, so I will write force up plus force down. So what are the forces on the y? Given the mass is 1 kilogram, so I'm gonna find the force of gravity, which is equal to mass times g. Mass is 1 kilogram and the g is 10 meter per second squared, so giving me 10 newtons, which is also equal to the weight. So the force up is 10 newton as well, so you have 10 newtons because it's of equal magnitude as the normal force, equal as normal force if they are all perpendicular to each other. And then force down, negative since it's going down, and that gives me 0. Is the object accelerating on the x? No, 0. Is the object accelerating on the y? No, 0. Now let's move to number 2. A 5 kilogram squirrel is flying from a tree to the ground at a constant velocity. So this is my key concept there. Consider air resistance, so there is no air friction. Diagram force, moving at a constant velocity. Object is acted upon by force of gravity, and ignoring air resistance, or consider air resistance, so we're not gonna ignore it, F sub air. So forces on the x, definitely none, 0. Forces on the y, so if I'm gonna find force of g is equal to the force of air, because if you look they have the same magnitude, so it's equal to mass times g. Mass is 5 kilograms and then g is 10 meter per second squared. This gives me 15 newtons. F sub g, which is equal in magnitude as F sub air, so F up plus F down. So the F up is 10 as 50 newtons and the F down is 50 newtons, but it's going in the negative, so I'm going to write the negative, gives me 0. Is it accelerating on the x? No, it is not, so 0 meter per second squared. Meter per second squared, meter per second squared. So we'll try to write those units. Is it accelerating on dy? No, but it is moving at a constant velocity, so take note of that. Doesn't mean the object is not accelerating, the object is not moving. Let's move to number 3. An egg with a weight of 0.10 newton is free falling from a nest in a tree. So let's free falling, so that means in this case we ignore air resistance, so only the force of gravity. Let me find force of gravity is equal to m times g, which is equal to mass of 0.10 Newton. Okay, so that is on the X 0. So what are the forces up? What are the forces down? So the force up is 0 newtons and the force down is negative 0.10 newtons. Therefore the object is in motion. It gives me 0.10 newtons. Is the object accelerating on the X? Is it moving horizontally? No. So 0 meter per second. But it is moving vertically at a constant rate of 9.8 meter per second squared, or 10 meter per second squared. Now let's move to number 4, a 2 kilogram object that is tied to a rope. So anything that's tied to a rope must have a, you're right, tension force. So let me draw a free body diagram. First, force of gravity, and then the tide accelerate upward at a rate of 1.5 meter per second. So here it tells you the acceleration going up. We're gonna ignore a resistance, so we will just have a tension. So it's going up, then our tension would be a little bit longer than the force of gravity. So we're gonna find that tension. So in order to find the tension, we'll multiply that to the mass. And if it's accelerating upward at a rate of 1.8, so is it moving on the X? No. So there's no acceleration. Is it moving on the Y? Yeah, definitely. But by how much? So that's what we're gonna deal with. So if it's moving, so if the force of gravity is, so force of gravity is equal to mass times G, which is 2 kilogram times 10 meter per second squared. That gives you 20 newtons. So that is 20 newtons in here. Or if you use 9.8, you'll end up with 19.6. Okay, if you use 9.8 here, you end up with 19.6 here. So let's just round it up. So what will be the tension in here? So if the object is moving, so we're looking for F, and if the mass, so if the mass, so tension, so I'm gonna look for Y here. So the Y, which is tens, okay, is equal to the mass times the acceleration, which gives me 2 kilograms times 1.5 meter per second squared. So the tens is 3 newton up. So that 3 newton up gives me an idea that the tension would be 20 plus 3. So 20 newton plus 3 gives me 23 newtons. This gives me 23 newtons. So that is it, and I'll give you some time to practice. So is it accelerating? Yes, it is accelerating at a rate of 1.5 meter per second. So let's look into the other page. So I'll give you some time to work on this, and we'll find out the answer later.